Hello and welcome to another 3D printing video. This video's topic is 3D printing technologies, photopolymerization in specifically, and SLA, MSLA, and DLP technologies. So first off is SLA, which means stereolithography. It's based on a UV laser and a resin that hardens under UV light, or especially in this case, UV laser. It works so that there's a build platform, which you can see in the image on the top, that is lowered into the build vat or the resin vat, which is filled with resin in the middle part of the image. That is filled with resin, and the build platform is lowered there. And then an UV laser creates the layer, curing and solidifying the resin itself. The laser beam is focused on the path already determined in the slicer software. So the slicer software calculates the path where the laser has to move and go so that it solidifies the layer fully. It solidifies the right places for the layer. And once that layer is solidified with the laser, the build platform is raised a bit, peeled from the resin tank a bit, and then moved up like 10 millimeters, and then lower back down onto the second layer. So same position as last time, but like 50 microns higher. And that step is reproduced again and again and again until your part is finished. And under the resin tank, you can see a laser, and that laser is guided with mirrors, so it can hit every and each corner of the resin tank. And what about the resin tank itself? Well, the resin tank's shell is usually made out of acrylic or metal, and bottom of the resin tank is transparent, and it's coated with an elastic coating. So it's thick, and it usually has an elastic coating inside of it, so it helps with the peeling of the print from the bottom of the tank. Because when the laser hits, even though the build platform is lowered so that it hits the resin tank's bottom, print still gets stuck a bit on the resin tank's bottom itself. So it's a good idea to have some of elastic coating or something that helps with the releasing of the print from the bottom of the resin tank. And the resin tank, the build platform, and the laser, they're all consumable parts. The resin tank, for example, with one manufacturer, is said that you should use only one type of tank for each of your materials. And the build platform itself, you need to change it once it reaches a certain level of use so that it doesn't work anymore. You need to change it. They have some costs on them, those. And the laser, well, that's a rare part to break, so it should work for a few thousand hours at least. The galvos themselves might have some difficulties, but usually it's so that the laser works really long time. So the resin tank and the build platform are specifically the ones that need changing. So what type of printers we have in this category? Well, in the industrial side, we have 3D Systems Prox 950 and Stratasys Flex B650. These are good industrial SLA printers, and they have quite big build volumes, so 1.5 meters by almost 1 meter by 0.5 meters has the 3D Systems one, and Stratasys have like 0.5 meters by 0.5 meters by 600 millimeters. But they're both quite expensive because they're industrial printers, so they're both like way past 200,000 euros. The 3D Systems one is it's around 500 to 1 million euros. 500,000 to 1 million euros. But what about the consumer printers? Well, there's few options there. These are just a few, just two Obviously, there are more industrial printers than those two that just mentioned, but those are two good examples. And what about the consumer part? Well, there's the Formlabs Form 3 and Photopolymerization. Those are two of the one good consumer printers, but they are still too very pricey compared to like FDM 3D printers. But the quality is like superb. I mean, the print quality is really, really good. And the build volumes is they're both kind of small, as you can see on the Formlabs Form 3. It's like 15 centimeters by 15 centimeters by 19 centimeters around, and it costs 3,500 to 4,500 euros, 4,200 euros. And then there's the Photopolymerization, which has smaller build volume, and it costs like 1,200 euros. The resolutions on these both printers are really good, even if we compare with the industrial ones, they almost reach the same level of resolution, or even better if we compare to the Stratasys Flex, for example. As you can see there, it's like 127 microns on the XY resolution, and in the Moai and Formlabs it's 70 microns and 25 microns on the Formlabs. So what if we go to another machine or another technology inside the photopolymerization technology? We go to the MSLA, which stands for masked stereolithography. So basically this uses the same materials than with an SLA machine, but it's based on another principle. This technology works so that it has a UV LED underneath the resin tank, and underneath the resin tank there's also an LCD display. But otherwise it's completely the same. So there's the same build platform, and then there's the same resin tank. Okay, the resin tank also has a bit of a changes into it, but we'll go on those later on. So there's an UV LED and then an LCD display. And the LCD display shows the image of the layer that needs to be cured. As you can see in the image, it's showing a layer that is white, and the other parts of the image is black. So the white part is the part where the UV light can pass through the display, and the black parts are parts where it cannot pass. So all the parts where the UV light passes the display are then hardened. And when that is done, the build platform peels itself off from the resin tank and then raises a bit more and then lowers back down. On SLA, the laser moves to cover the whole section, but on MSLA, you can print the whole layer at one time. So MSLA can create one layer in like 2 to 10 seconds, depending on the display used. So there are like mono displays nowadays that only output monochromatic colors, and manufacturers have noticed that this speeds up the time for the print like 4 times. So before using normal LCD displays, the printing time was like 8 to 14 seconds per layer, but nowadays using monochromatic displays, it's 2 to 4 seconds per layer, and the mono displays they last a lot longer. The earlier ones, the normal LCD displays, lasted like 2 to 300 hours, but nowadays the monochromatics are set to last 2,000 hours. So that's quite a difference. So what about in the MSLA, the resin tanks? The resin tanks chassis are usually made out of metal, but there are some acrylic options that like aftermarket or third-party options, but usually the ones that come with the manufacturer, they are all metal. And compared to SLA, in an MSLA resin tank, there's nothing on the bottom, so it's empty. You can punch your hand through there if it doesn't have this thing called FEP film. And that FEP film is then attached to the bottom of the resin tank. So it acts as a shield for the resin tank, so obviously the resin doesn't then drip on the LCD display. So this FEP film is a part again which is an replaceable or consumable part, which you need to replace time to time when the prints don't get stuck on your printer again. They don't work out, so to say. You have to change out the fab film, for example, or level your printer. And then the LCD display is usable, and the UV LED is usable. Consumable. So you have to change those two. So on top of fab film, which costs like 5 to 10 euros a piece, and then there's the LCD display and UV LED that need changing from time to time. LCD display, obviously, if it breaks or if it just stops working, like after the 200 to 300 hours on the normal display, you need to change it. But it's really an easy operation to do so. And the UV LED, obviously, when it stops working, you need to change that too. But again, this doesn't cost that much. Fab films are like I said earlier, 5 to 10 euros. LCD displays are like 30 to 100 euros, and UV LEDs are like 20 to 50 euros. So they are quite cheap. So what about the printers in this section? Again, we go through the industrial sector and then the consumer. Industrial, there's the 3D system figure 4, which is thought out to be a modular one. So you can like attach several of these printers next to each other and then just print away. It has like this ecosystem, so to say. And as you can see in the build volume on the figure 4, it's not that big. So it's 125 millimeters by 70 millimeters by 350 millimeters. And the price is like over 25k to 50k. And then there's photocentric magna. And that build volume is quite big. So it's half meters by 30 centimeters by 35 centimeters. And that costs 22,000 euros. So you can create really big prints. You can create magnificent prints with this machine. What about consumer printers? There's the Photopolymerization, which costs 300 euros. The build volume is 27 centimeters by 15 centimeters by 40 centimeters. That's quite big again. And then there's the smaller one that is comparable basically to the figure 4, but a bit smaller. The build volume is 120 millimeters by 68 millimeters by 155 millimeters, and it costs nowadays, I think it costs around 200 euros. So 260 euros. Some sellers will still sell it on that price, but you can get it for 200. What about the third one? So under photopolymerization, there were 3 technologies. There were the SLA, MSLA, and DLP. And this is the third one, the DLP. So what is that? DLP stands for digital light processing. Basically, exactly the same things done with the other technologies, SLA and MSLA, but there's no UV LED, there's no laser, there's a projector which lights the resin. This works in the same principle than the MSLA, so it lights up the whole layer at once, but it uses a projector. And the resins that you use with MSLA and SLA don't work with DLP because the projectors that are used don't emit UV light. So this is basically rarer technology nowadays because of development of MSLA and other significant printing technologies. When first consumer SLA printers came, this was a rising star, so to say. It showed really good potential, but then it didn't just carry on because the SLA printers they showed up to be really good, and then a few years went by, and then came the MSLA printers, which made these machines pretty much obsolete because DLP printers are a bit more expensive than the MSLA, for example. And the DLP resin tanks works in the same way as with the MSLA, but in this technology again, projector lamp is consumable. The resin tank is either acrylic or metal. So applications for these 3 or this one major technology. Well, small figures. Obviously, you can create figurines for your role-playing session, tabletop gaming sessions, or you can create these as your just decoratives and paint on them on whatever you want. Or you can create jewelry, or you can create jewelry, On the left hand image, that is not made out with SLA or MSLA or DLP, but it shows the basic idea that you can really make the same things with this technology. And on the right hand side, it shows a ring made out with this wax type of material first, and then cast with silver and then polished into a final ring. So you can make rings, earrings, amulets. First you print out the mold and then just cast it with the material you want, and you're good to go and get jewelry as you want. It eases out the jobs for the jewelers quite a lot, so they don't have to create everything from scratch. They can use these molds, so to say. There's molds. So this whole figurine or part first was done with SLA machine, the mold part, and then it was cast out with polyurethane resin. So you can use it for that. This will be a lot more detailed than done with an FDM 3D printer, for example. And you can use it in education. On the left hand side, it's this thing called basal ganglia, which controls our fine motoric movements and such, and our balance. It's a more effective way to show the students, if you have something physical in your hands, than show the images on your textbook or on your computer. You can pass these around and the students can see how it really looks like, compared to just looking at the images from the book. So it gives like a new way of learning, so to say. And the right hand side, there's 3D printing models for educational purposes. There's the transparent full heart model demonstrating normal anatomy. So again, used for educational purposes. You can print out a heart. Then there's the dental side. You can print prototypes before making any great surgeries, or when you're planning on your dental project, so to say. You can test out different sizes or the different shapes of the tooth before even doing the real tooth itself. So what about the technology itself? Well, this printing type, or this printing, always requires supports. So every time you want to print, you will need to use supports, unless it's a flat part. Then you might manage with just inserting it onto the build platform. The printing temperature on the ambient temperature should be around 20 to 30 degrees. If it's lower, then the viscosity on the resin is bad for printing, and you won't get any successful prints. And another important thing is the current orientation for the print. So you need to always orient your parts. Unless you orient it correctly, you will have problems again having a successful print. And then the materials, they aren't that rigid or durable. So these are for showcase purposes or molds or like stuff like that. But they are, well, can't say that there are a few exceptions for the special materials that withstand technical requirements, but usually they are for showcase or such purposes. What about the pros and cons on this technology? Well, there's the printing speed on MSLA and DLP. Then there's the accuracy and details. You can get really detailed prints with this technology. Like you can create small scale fences that have like this barbed wire that is 0.5 millimeters in size, and it will come up quite nicely. And it's a relatively cheap way to start printing. So it's, as you saw in the consumer ones, it's 200, 300 euros for a printer. Consumer parts are easy to change. You just take the power off, and take the part off, and be careful, and then just change it. And new materials are being developed. So to meet the technical requirements, new materials are being developed. It's easy to post-process. You just you can sand it, you can coat it, you can paint it, whatever you want. And then it might be for mass production. Again, thinking which technology to use and what you're printing. If you print big parts, then it might not be for mass production, but if you print dozens and dozens of smaller parts, you can fill the whole build plate full of them and then just print away. But obviously, there are cons. The materials really are not for technical purposes at the moment, not everything. And they always require supports. And removing supports might be tedious sometimes, and the support might leave a bit marks like these little dots or like these little spikes. And consumable parts cost money when we're talking about with the major manufacturers, major printer manufacturers on the SLA and part, for example, it's like 100 or 150 euros for one resin tank, so it's very costly. And the chemicals, you have to play around with chemicals for mostly with isopropyl alcohol, and that is that's something that you don't want to breathe in hours and hours. And then the resin themselves are really bad chemicals too. You don't want to touch them with your bare hands, you don't want to sniff them around, so you need to have a very well ventilated space where you're using the printer. And then there's the UV light, so if some printers don't have a good filtering, that's not good for your eyes. And then the build volume is quite small still on the smaller ones. It's getting bigger and you're going to buy bigger prints, but they obviously cost more. And once the print is finished, you have to post-process it in isopropyl alcohol, so you get the extra resin out of the print. And after that, you have to dry it out and then put it under UV light, so you still harden it a bit more. So you harden all the left out resin that's still on the surface. So you must get rid of that. If you don't harden it, it will the print will feel tacky or sticky. And one bad thing is that UV light keeps hardening the print. So if you take your print outside, it keeps hardening under the sunlight, and it will become hard, very hard, and it will break very easily after that. So it should be coated painted, for example. And most materials are hard, and they break easily because of this. If you drop it on the floor, it will shatter into pieces, the common ones. But otherwise, if you weigh out the pros and the cons, if you have a good ventilated space, and if you can do with the chemicals, and if you have your safety precautions, it's a great technology. It's a great way to get good quality prints out. But that's about for this video. I hope to see you in the next one. Bye bye.